Okay, on number 15 it says the figure below shows a cone with a 1-inch radius and a height of 2 inches. A new cone is constructed with a radius measuring 3 times the radius of the original cone and the height measuring 3 times the height of the original cone. What is the ratio of the volume of the second cone to the volume of the original cone? You do not have to find the volume of these two different cones in order to know the ratio of their volumes. Since you are tripling the radius and the height, and those are the two dimensions in the volume of a cone, you are creating a similar solid. So remember, if you're creating a similar solid, you could use our theorem that we learned, that if you know the ratio of the linear dimensions, then to find the surface area ratio, you just square that ratio. And to find the ratio of the volumes, you just cube that ratio. So since we're tripling the radius and the height, we're creating a similar cone. So my ratio of my two cones is, the second one is 3 times as big as the first one. So that would be a 3-to-1 ratio for the linear measurements, or 1-to-3, however you want to look at it. So you're going to take that linear ratio and you're going to cube it to find the volume ratio. So 3 cubed is not 9, that's 3 times 3 times 3, which is 27, and 1 cubed is just 1 times 1 times 1, which is 1. So I can see that the volume will have a 27-to-1 ratio without even finding the volumes of the two cylinders. Now, if you want to, you can find the volume of the two cylinders and compare them that way, or you can use your formula for the volume of a cone and replace the R with 3R and the H with 3H. So you would have 1/3 pi 3R squared times 3R. I'm sorry, 3H. So 3R squared, 3R times 3R is 9R squared. And so now I can see, I can remove these 9 times 3 to the front, which is 27, and then I have it times the original volume of 1/3 pi R squared H. So I can see my original volume has been multiplied by a factor of 27. So several different ways that you could work this problem, this being the easiest, this being the next easiest, and probably the hardest would be finding the two separate volumes and comparing them that way.